my notes. Is it? Yes, okay, good. Yes, okay, perfect. Okay, awesome. Okay, so I don't want to lose you guys, but okay, perfect. Let's get to work. Okay, so again, yeah. Okay, 5.1, calculate probabilities given a uniform density curve. Calculate probabilities given a standard normal density curve and the inverse. Okay, recall what is a distribution. Okay, distribution are the possible values. Okay, possible values. Okay, and two, it's the frequency and the probability that those values are going to occur. Okay, so remember the histograms that we did, you know, think histogram, okay, frequency, and then the cumulative histogram, or sorry, the relative frequency histogram was the probability that that's occurring. Okay, so we're going to talk about the probabilities. Example, create a table and draw a graph of the distribution of the outcomes when rolling a die. Okay, so what would be a graph of the distribution of the outcomes of rolling a die? Well, there's 6 possible possibilities, right? So x and p of x. And so we're going to do 1 through 6. 1, 2, 3, 4. I'm going to run out of room. Let me erase this. Okay, we go back up. X and p of x. Okay, 1, 2, 3, 4, 5, and 6. And what are the probabilities? Well, the probabilities are 1/6 for each of these guys, right? 1/6, 1/6, 1/6, and 1/6. Okay, 1/6. So what would be the distribution? What would the distribution look like? Well, we'd go 1, 2, 3, 4, 5, and 6. And then if we had 1/6, well, they would all be at 1/6. Okay, and so this would be the distribution of rolling a die. Okay, it's all 1/6. Okay, a density curve is a graphical representation of a continuous probability distribution. So this is what we would call discrete. Okay, a discrete density curve. Okay, it comes in whole items, 1, 2, 3, 4, 5, and 6. Okay, sorry, like that. Okay, a density curve is a graphical representation of a continuous probability distribution. So this one's continuous, which means that the probability is not represented by the top value. The probability is represented by the total area. Oops, again, that's hard to see. Area. Okay, it's the total area. The requirements, the total area under the curve must equal 1. And number 2, every point must have a height greater than or equal to 0, meaning no negatives. Cannot have any negatives. And so when we talk about a normal curve or a bell-shaped curve, okay, this is a probability distribution, and the area under the curve equals 1, and all of the probabilities are represented by area. Okay, so it's not what's the probability of getting a 1, it's what's the probability of getting 1 through 5, basically. What you have to take the area here. Okay, it's not, you're not saying, oh, the probability of getting 1 item, it's the probability of getting, say that these were heights, say maybe 1 foot to 5 feet. What's the probability of having 1 foot to 5 feet on something? Okay, not the probability of getting exactly 1 foot, because you couldn't really get exactly 1 foot. It would be 1.000001, and we're looking at a range of values for a continuous probability. Okay, so the area is equal to the probability. Okay, total area equals probability. Okay. The uniform distribution is continuous. Okay, uniform distribution is continuous. Okay, now this distribution that I drew here is not uniform. This is not uniform. This is what we call a normal distribution. Okay, that's a normal distribution, okay, or a bell curve. Okay, a uniform distribution, okay, looks like this. Let's draw a picture of it, okay. It is basically, say that we go from, again, 1 to 5. Let's just do that, 1, 2, 3, 4, 5. 1 to 5. It's basically a rectangle. Okay, that is the uniform distribution. It is a rectangle. All probabilities are equally valid. Okay, and it's the area between two values. Okay, it's the area between two values that form this, the probability. Okay, the density curve has a rectangular shape. Okay, and so here's how I figure out the uniform distribution. Okay, so say that the uniform distribution goes from 1 to 5. Well, what I do is I take the range and I do 1 over the range. 1 over the range, that will give me the height of the rectangle. How high is that rectangle? Well, what's the range here? Well, the range is the highest number minus the lowest number. It's that 5 minus 1. So 5 minus 1 is 4. And so the height of my rectangle is 1/4. 5 minus 1 being 4. Okay. So the height is 1/4. So if I want to, and why is that? Because the total area has to equal 1. The area has to equal 1. The area has to equal 1 there. Okay. And if the area has to equal 1, then, well, what's the range? What's the width of my rectangle? The width of my rectangle is 4. What's the height of my rectangle? It's 1/4. And so what's 4 times 1/4? Well, it's 1. So the area, we would say here in my example, is 4 times 1/4, which is equal to 1. So going from 1 to 5 gives me my whole area, or all my probabilities of occurring. Say that this is the minutes. The minutes, you know, between, are the minutes, we'll say that this is the minutes for somebody holding their breath. I don't know, something silly. Okay, say most people could hold their breath for a minute, okay, all the way up to 5 minutes, and we're not going to say that anybody, and the probability of holding their breath is uniform. Okay, something like that. Okay, it's really not, but for the sake of this example, we're going to go with it. Well, we're going to say that 100% of the people can hold their breath from 1 to 5 minutes. Okay, and so what would the probability of holding your breath from 1 to 2 minutes be? Well, it's actually real easy to get the probability. Let's just write it up here. The probability from 1 to 2 minutes is the width, right? It's the width of that times the height. It's the width of that times, I'm going to put a different color here. And I'm going to say, hey, we just want 1 to 2, right? We just want 1 to 2. Well, what's the range from 1 to 2? Well, yeah, it's just 1, right? The range from 1 to 2 is just 1. So this would be 1. And then what's the height? The height is that 1/4. So that's just 1 times 1/4. Okay, which is equal to 1/4. So the probability of holding your breath from 1 to 2 minutes is 1/4. Okay, if we wanted to go from 1 to 3, it would be 2/4. Okay, from 1 to let me get rid of this 4. That's confusing me, having that 4 there. Okay, go back to red. So this is 1, 2, 3, 4, right? So from going from 1 to 3, okay, that would be 1/2, which makes sense that that's 1/2 or 2/4. Okay, what about 1 to 4? Well, that's 3/4, and then 1 to 5, the whole thing is 4/4. Okay. So let's see how this works out in another example here. For New York City, weekday, late afternoon subway travel from Times Square to Met Stadium, you can take the number 7 train that leaves Times Square every 5 minutes. Okay. Given the subway departure schedule and the arrival of the passenger, the waiting time X is between 0 minutes and 5 minutes, and all waiting times are equally likely. Draw a density curve. Okay. So instead of 1 to 5, like in my previous example, we're going to go from 0 to 5. Okay, from 0 to 5 here. Okay, which means that my height is going to be what? What is my height going to be? Well, if we take the range here, 5 minus 0, the range is 5 minus 0, which is 5, and we put 1 over 5, well, yeah, if you had said 1/5, you're correct. Okay, 1/5 is the height here, because it's 5 minus 0, and then 1 over 5 is the height. Okay, that's the height. So we've drawn our density curve here. Okay, and now it asks us, find the probability that a randomly selected passenger has a wait time of greater than 2 minutes. Greater than 2 minutes. Okay, so let's see. Greater than 2 minutes. What would greater than 2 minutes look like? Okay, so let me erase this guy underneath. Okay, greater than 2 minutes would be at the 2-minute mark to the 5-minute mark, and everything in between the 2 minutes to 5 minutes, right? So everything in between 2 minutes to 5 minutes. Well, how are we going to find the area of that rectangle? Remember, the area for the whole thing is 1. Why? Because it's 5 times 1/5, which is 1. It's a probability of getting on a bus, you know, at any point in time here. Within any 1 minute is 1/5. 1/5 is the time you're going to get on in 1 minute. 1/5 in 2 minutes. 1/5 from 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Well, how many fifths do we have here? We have 2 to 3, 3 to 4, and 4 to 5. That's 1, 2, 3. 3 times 1/5. Okay, so 3 times 1/5. So we say the probability that X is going from 2 to 5, okay, is equal to 3, which is the width that we're looking at, times the height. Let's make that 5 a little bit better. 3 times 1/5, which is 3/5. Okay, so that's 3/5. So the probability of getting on a bus between 2 and 5 is 3/5, which should kind of make sense, because you don't know when, you know, if the bus comes every 5 minutes, you don't know when you showed up. Did you show up in the 1st minute? Did you show up in the 4th minute? You don't really know that. So we're saying that, you know, if you show up in the 2nd minute, then you've got a 3-minute wait time. Okay, but you don't know. Okay, and it's just as equally likely that you would show up at any point in time. Okay. Okay, let me just check on things here. Okay. Okay. Okay, let's do example number 2 here. Okay, example number 2. A random number generator on a computer is programmed to select two numbers between 1 and 4. What is the probability that both numbers selected are greater than 1.5? Draw a density curve. Okay. So randomly select two numbers between 1.4 or 1 and 4. Now we're going to assume that you could have, decimals, 1.3, 1.7, 1.45. Okay, and so this is not going to be discrete. This is going to be continuous. Okay, so each value is equally likely to show up. Okay, and so from 1, 2, 3, 4, I'm going to draw a rectangle. 1, 2, 3, 4. Okay, what's the height of the rectangle? Yep, if you said 1/3, you're right. Okay, so 4 minus 1 is 3. 1 over 3 is 1/3. Okay, so this is my density curve. Find the probability that both numbers selected are greater than 1.5. Okay, so 1.5 is here. Okay, and then greater than 1.5 is going to be this. So we want the probability that x is greater than 1.5. Okay, well, what's the width from 1.5 up to 4? So let's look at the width. The width times the height, right? The height. Okay, so the width is going to be the distance between 4 and 1.5. Okay, so let me move my 2 over. Okay, that's 2. This is 1.5. I guess I should have drawn this bigger. Okay, 1.5. Okay, and so, well, what's the width? The width is 4 minus 1.5. Okay, times the height. Well, what's the height? The height is 1/3. Okay, and so this is 2.5 times 1/3. Okay, which is equal to 5 halves. This is 5 halves. Okay, which is equal to 5 halves times 1/3, which is equal to 5/6. Okay. Okay. Now, we have to go back and see, well, that's the probability for 1. It says a random number generator on a computer is programmed to select how many numbers? It's 2 numbers. 2 numbers. So the probability that we would get one number to be between 1.5 is 5/6, but we now want the probability of selecting 2 of those numbers. And so we really, because there's two numbers, we're going to do 5/6 times 5/6, which is 25/36. So that's the probability that 2 numbers would be there. So yeah. Okay. Okay. Okay, we're going to move into 6.1. Are there
Professor, quick question.
Yeah, sure.
Why did you convert the 2.5 into fractions?
Just to make it a little easier to multiply, I either had to convert the 1/3 into a fraction, or I had to convert the 1/3 into a fraction, or I had to convert convert the 1/3 into a decimal, or I had to convert the 2.5 into a fraction. The 1/3 is kind of messy. It's 0.3 repeated forever. Okay. And so I just decided to convert the 2.5 into a fraction because it ends up being a little nicer.
Okay, thank you.
Sure. Okay, any other questions on anything? And we're going to move into 6.1 now. Okay, more continuous distributions. Okay. Okay, now we get into really the crux of statistics, okay, and that's the normal distribution, okay. You know, all roads in life lead to the normal distribution, okay. It's the bell-shaped curve. It's why we've been talking about z-scores and what everything has basically been gearing up to at this point. Okay, so this is the bell curve, okay. We have something called the empirical rule for the bell curve, and that's the 68, 95, 99.7 rule, okay. And basically what this says is that 68%, okay, are within one standard deviation of this normal curve. This is the normal curve, right? The area under this curve, okay, the area under this curve is the probability. Because it's a continuous probability, the area under the curve is the probability. So it behaves very much like the uniform distribution, except that it's not uniform. The area equals 1. The total area is equal to 1 or 100%. Okay, we're talking about percentiles and percentages. Okay, and so the area is equal to 1 or 100%. And we say that within one standard deviation of the mean, remember that mu is the mean, right? Okay, within one standard deviation of the mean, 68% of the data lies within one standard deviation. So within one standard deviation here, 68%, and we'll color code this, 68% is within one standard deviation. Okay, so we have, maybe we'll make this purple. Okay, so inside here, okay, is 68% of the data. Okay, or 68% of the area is contained under, okay, under this curve, 68%. Okay, so let's see if I can do this a little nicer. 68% is inside here. Okay, so that's the big 68% is in these boundaries. Okay, once I go outside of these boundaries, it's no longer 68%. Okay, so 68%, okay, is within one standard deviation. 68% is within one standard deviation of the mean. Okay, if I go out two standard deviations, okay, if I go out two standard deviations, I'm going to get rid of this. Okay, two standard deviations, then what is the two standard deviations here? Well, looks like this. Maybe we'll do gold on this one. Okay, two standard deviations is all of this area. Okay, so this is two standard deviations. Okay, I'll do 95%. Okay, and this is two standard deviations. Okay, for the bell-shaped curve. So 95% is within two standard deviations of the mean. Okay, 95% is within two standard deviations of the mean. Okay, so it includes that 68%. Okay, it's just not these tails over here. That's not what we're talking about. We're not talking about just the tails. We're talking about the whole thing. 95% of the data is within two standard deviations. Okay, two standard deviations. Okay, and then what about almost the entire thing? Almost the entire thing is three standard deviations out. Three standard deviations out is basically basically almost the entire thing here. Okay. So we'll go back to our red. Okay, almost the entire thing. Okay, except for these little pieces out here that are not a part of it. Okay, is 99.7%. Okay, 99.7% is basically, okay, everything out to 3 standard deviations within the mean, okay, is all the way out, except these are not included. Okay, not included. Okay, this is not included. Okay, and then I'm going to go back to this guy. Okay, and so we say that uh, 99.7%, okay, is within 3 standard deviations of the mean. Okay. Okay. Okay, does that make sense with the area? The areas, yes. Okay. So the bell curve, areas under the curve. Okay. Okay, remember that a z-score, okay, is x minus mu over the standard deviation. Okay. So if I'm given values, okay, that are not standardized, okay, the standard normal curve looks like this. Okay, it has 0 in the middle, and then 1, 2, and then 3, and -1, -2, and -3. So that's the standard normal curve. Okay, standard normal. Now, if it's not standardized, then I have to standardize it. I don't even know if that's a word. I have to make it into a standard normal curve. And the way we do that is with our z-score. Okay, so we standardize this, that what would be non-standardized. So we would take values, say, like 68, okay, 70, 72, right, and 66, and 64, and 62, okay, and these are non-standard values. So how would we turn the non-standard values into standard values, right? How do I know how far away 68 from 70 is? Well, I have to calculate a z-score. Well, how far away is 68 from 70? Well, that depends on the mean and the standard deviation, okay? Mu and sigma. It depends on what mu and sigma are. Okay, so let me draw my mu a little better. Okay, so mu in this case, I'm going to say is 68 and sigma is 2. And so now I know how far away these are on a standard normal curve. Okay, if mu is 68, which is in the middle, okay, and and sigma is, we said 2, then I could tell, oh, well, if 68's in the middle, how far up would I have gone to get values between 66 and 70? That's our first example here. It says golf scores for a school team are normally distributed with a mean of 68 and a standard deviation of 2. So 68 and a standard deviation of 2. Find the probability that a golfer scored between 66 and 70. Well, if we look at 66 and 70, if we calculate these z-scores for 66, 70, and 68, well, what do we get? Well, I'm just going to calculate one of them. Let's calculate 70. So z is equal to x minus mu over sigma. Okay. And so what's x? X is the value that I'm looking at. So we'll say that I'm looking at 70. 70 minus 68 over 2. Well, what's this? This is 2 over 2, which is 1. So this 70 becomes a 1. Well, what would 68 minus 68 be? What if I plugged in 68 here? Well, what's 68 minus 68? Isn't that 0? 0 divided by 2 is 0, so wouldn't that become a 0? And what about 66? Wouldn't 66 minus 68 be negative 2? And negative 2 divided by 2, wouldn't that be negative 1? So wouldn't that become negative 1? Oh, yeah. And as you can imagine, 72 would be positive 2, and 64 would be negative 2. And if I went up to 74, okay, 74, that would be 3 and negative 3. So what we did was we standardized this now into a standard normal curve. Okay. Between what two scores does the team score 95% of the time? Okay. Well, we want to know that between what two scores, the probability of x being between what two scores is equal to 95% of the time. Well, we're going to use 2 standard deviations. Well, what's 2 standard deviations away from the mean here? 2 standard deviations in the negative direction and 2 standard deviations, in the positive direction, okay, would be that my scores would have to go, okay, because again, 95% of the time, we're within 2 standard deviations of the mean. 95% of the time, we're within 2 standard deviations of the mean. Okay, so how does that work? Well, okay, within 2 standard deviations, that's go down from the mean to 64 and go up from 68, 72. And so we would say that between 64 and 72, we're going to get 95% of our scores. Okay. Okay. Example 1, draw the normal model here. Okay, draw the normal model. Okay. Of example 1, okay, so we kind of did a quick sketch of it over here. Okay, let's do a nicer sketch. Draw the normal model. So this is going to be 68. This is going to be 70. This is 72. Okay. And this basically is 74. Okay. This is going to be 66, 64, and 62. Okay. Okay. So one thing that I want to emphasize here is that if these values from here to here are 95%, then these values on the tails have to add up to 5%, which means that each of them, okay, each of them is 2.5%. So let's just keep that in mind for a little bit later. Okay, so if the middle, it's the middle 95%, okay, the middle 95%, then the tails are 2.5% each, because they have to add up to 5%. Okay, and the whole thing has to be 100%. Okay, what percentage of scores would be between 68 and 70? Okay, so what percentage of scores would be between 68 and 70? Well, that's one standard deviation. Oops. Okay, that's one standard deviation above. I don't know why that moved on me. Okay, that's good enough. Okay, what percentage of scores would be between 68 and 70? Well, within two standard deviations, or sorry, within one standard deviation, okay, it would be 68%, right? So what would be half of this? I just want half. I just want this half. But within one standard deviation is 68%. Within one standard deviation is with 68%. So half of 68% is 34.34, which is 34%. So 34% would be between 68 and 70, because we knew that both sides create 68%, one side is 34%. Okay, find the probability that a golfer scores between 64 and 68. Okay, so the next problem is between 64 and 68. Well, again, it's basically the same problem, but now with 95%. Okay, so if two standard deviations is 95%, well, then what's half of that? Right, half of that, okay, is 1/2 of 95%, which is 0.475 or 47.5%. Okay, find what percentage of scores fall between 64 and 66. Okay, so that's kind of a little bit more interesting. Well, let me kind of erase a lot of what I've done here. Okay, except for the bottom. Don't want to erase that. Okay, so we want to know 64 to 66, right? Okay. Well, we knew that 64 to 68 was 47.5%, right? Okay. We also knew that 68 to 70 was 34%. So this was 34%, which means that this on the other side is also 34%. That's also 34%. And this whole thing here, okay, was 47.5%, right? That was 47.5%. I'm going to get rid of this 2.5, not 2.5 right there. Okay, so this whole thing, okay, in that rectangle, okay, it's not really a rectangle, but in here, okay, in there, okay, that whole thing was 47.5%. So if I subtract 47.5% from 34%, or the other way around, sorry, subtract 34% from 47.5%, I get this little piece that's left over, which is what I wanted. That little piece, okay, left over. The leftovers are 13.5%. That's what I was looking for. Okay. Okay, find a probability that the golfer scores higher than 68%. The probability that the golfer gets more than 68. Okay, what's the percentage here? Okay, or just the probability without a percentage. Okay, well, how much is higher than the middle? How much is higher than the middle? Well, the middle cuts the area in half. And so if I have the middle, which is the mean in this case, is at 68, then the upper half of this graph would be 50%. So the probability that a golfer scores higher than 68 is 50%. higher than the middle. Okay. Okay, find the probability that a golfer scores lower than 62. Ooh, that one's interesting. Lower than 62. Okay, so 62 is how many standard deviations away from the mean? Let's count them. Okay, if this was 0 and this was -1, then this was -2 and this is -3. So 62 is less than 3 standard deviations. So here's how I write this. I say the probability that x is less than 62 is equal to the probability that z is less than -3. Why z? Because I changed it to a z-score. And we could do that by doing our z calculation. Z is equal to x minus mu over sigma. And so x is 62 minus 68 all over 2. This is -6 over 2, which is -3. So that's a z-score of -3. I want to know what's the percentage that of everything lower than -3. Well, it's not 2.5%. That's what it would be if it was everything lower than -2. That would be 2.5%. Well, how much area is between, okay, is between 62 and 74? It's almost the whole thing. Almost the whole thing, not the whole thing. Almost the whole thing. Well, how much is between 62 and 74? Well, it's 99.7%. Okay. But the 0.3% that's left over, again, that's shared between the two sides. That's shared between everything less than 62 and everything bigger than 74. So I have to take this 0.3 and I have to divide it by 2, and that gives me 0.15%. And that is how much is above 74, or in our case, how much is below 62. And so this is equal to 0.15%. Okay, so a lot to take in. You know, it's just, you're going out from the middle and you're looking at the total area underneath this thing and how can we calculate those areas? Okay. Okay. Suppose a z-score in the standard normal distribution. Now this is how we represent standard normal distribution. That's the normal curve with a mean and standard deviation. And in this case, the mean is 0 and the standard deviation is 1. That's standard normal. Okay, I could have other distributions that are normal, but not standard normal. Just like in the last problem, we had a distribution that was n of 68, 2. This is non-standard. Non-standard. Okay, so this is standard, and this is not standard or non-standard. Okay, standard or non-standard. Okay, now we could turn the non-standard into standard. That's what we did before when we did our z-scores. Okay, but we're going to deal with the standard, just the standard for right now. Okay, so if I was to look at the standard curve, okay, the standard curve. Okay, so let's draw a big standard curve here. Okay, what are the percentages of the areas under the standard curve? Okay. Okay, I have a hard time drawing standard curves. You'd think I'd be good at it by now, but not as great as I could be. Okay. I'll call my daughter in here and she'll draw it for me. Okay, now I can actually do that because she's home. when I'm home. And we're home together like all of the time, which is, I don't know. So anyway. Okay, there we go. I'm just going to leave that as that. Okay, so this is 0. This is 1. This is -1. This is 2. This is -2. And this is 3 and -3. There we go. Okay, so we're going to use these lines as guidelines. Okay, merely guidelines. Okay, so from -1 to 1, what's -1 to 1? Yep, that's one standard deviation, right? That's within one standard deviation on both sides. That's our 68%. That was easy. Okay, what about 1 to 2? 1 to 2, well, we saw that before, okay, when we calculated this out, and if this was 34%, and this was 47, and the whole thing here, okay, out to 2 standard deviations was 47.5, then this thing was 13.5%. So that's another 13.5%. It's just we were looking at the one below before. Okay, what about z is greater than 2? Greater than 2. Yeah, that's kind of interesting. Greater than 2 here. Okay, so again, from 2 to -2, it's 95%, right? So what would be greater than 2? What would be greater than 2? Well, that would be, don't say 5%. It's not 5%. Okay, greater than 2, because we got to split that between the two tails. We've got a tail over here, and we've got a tail over here. We got to split that between two tails. Tail of two tails. Tail of two cities. Anyway, whatever. Okay, tail of two tails. Okay, so we've got two tails here. So you're right. It's 2.5%. Very good. 2.5%. Okay. I used to joke that I got paid to talk to myself. Now I really get paid to talk to myself. No, I'm just kidding. Okay. Yeah. Okay, P is Z less than 1. I can't tell any more jokes because everything's recorded now. So the jokes are all gone. Sorry. Okay. Okay, Z is less than -1. What's Z is less than -1 going to be? Let me get rid of some of this. Some of this stuff here. Okay, let me draw my curve back. Okay. Z is less than -1. So that's going to be this guy and this guy. That's interesting. What's that going to be? What's that going to be? Well, I know that this thing is 3 standard deviations, right? 3 standard deviations. It's everything, sorry. It's everything from, let's do the opposite side here. Okay. Okay, whatever. Okay, so we want everything lower than -1, right? Everything lower than -1. Okay, so we got to kind of think of what's not here. Well, what's not here is everything above 0, right? Everything above 0 is not there. And so what's everything above 0? Everything above 0 is 50%. So I know that 50% of that is gone. 50% is gone. So what's below 0? Below 0 is 50%, right? So that's 50%. Okay. Okay. Okay, but of this 50%, what is not there? What's not there? Well, it's half of the 1 standard deviation. Well, within 1 standard deviation is 68%, right? So within 1 standard deviation is 68%. So half of that was 34%. right? And so we know that this is going to be 50% minus 34%, which is 16. Whoops, I'm on the wrong one. My bad. This is 50% minus 34%, which is 16%. Okay. Okay. What about from -1 to 3? -1 all the way up to 3. Okay, -1 all the way up to 3. Now, this is gonna be a pain to calculate all these things by hand, and we're not gonna. That's why we're not gonna do it in a second. But we'll just get through these last two here. Okay, because we got to use all these different percentages to get here. Okay, so let's first ask ourselves, how much is it? Let's break this up. I'm going to break this up, okay? Just to make it easier. Okay, the probability from going from -1 to 0 plus the probability of going from 0 to 3 should be the same as the probability of going from -1 to 3. Okay, so that's what I'm going to do there. Now we just saw going from 0 to -1, that was 34%. Okay, that was easy. That's the easy part. Okay, and then what is the probability of going from 0 to 3? 0 to 3. Well, if 3 standard deviations above and below, so three standard deviations above and below is 99.7%. Well, what would be half of that? Just from 0 to 3? Well, I would divide by 2, right? So what's 99.7 divided by 2? Is 49.85%. And if I add that to 34%, I get a total of 83.85%. Okay, 83.85%. Okay. Okay, what about the last one here? -2 to -1. -2 to -1. Okay, or sorry, +1. -2 to +1. So from 0 to -2, this we already calculated was 40. It was 95 divided by 2, which is 47.5%. So from 0 to -2 is 47%, or 47.5%. And then from 0 to 1 was 34%. Okay, so this total is 81.5%. Okay, so we have this, which was 34%, and we have this over here, which is half of 95, which is 47.5%, and we add the two together, and we get all the percent between -2 and 1. Okay. Okay. Like I said, this can be a pain to do by hand, and so we're going to focus on using calculator to calculate these areas for us. Okay, so you can calculate them using a table. We're not going to do that. I'm going to calculate them using StatCrunch and the calculator. Now I'll do StatCrunch once, and then I'm going to use the calculator exclusively from then on out. Okay, just because I like the calculator, and I think it's good to use. Okay. Okay, calculating the area, 6.2. Calculating the area. Okay. Under a normal density curve is equivalent to finding the probability given a normal distribution. Okay. So 4 common cases are when A and B are z-scores. Okay. So when z is less than A, when z is greater than A, when z is between A and B, and when z is between negative A and A. So what does this look like? Again, when dealing with normal standard or with normal distribution, okay, I should write this somewhere. With normal curves, always draw a curve. Always draw a curve, okay? Always draw the curve. It's really hard to visualize this stuff, and you're going to need to draw the curve. Okay, so what would z less than a look like? Well, let's draw a curve, and let's say that a is here, and so we want all the value less than a. Okay, cool. Okay, what about z is greater than a? Well, we would want all the value greater than a. Okay, cool. Okay, what about from A to B? Well, we would want all the value. Okay, oops. We want all the value from A to B, and A can be any values. Okay, all the probability from A to B. Now, what about from negative A to negative or positive A? Negative A to positive A. Well, that's going to have some symmetry involved. Okay, some symmetry involved. And so if we look at the mean here, okay, we should be symmetric between negative A and positive A, which means we really could find out just the probability from 0 to A and then double it. Okay, this is equal to the probability that Z goes from 0 to A doubled, equals, no, I'll do this, equals 2 times the probability that Z goes from 0 to A. I'll get rid of that one. Okay, because of the way that the normal distribution is symmetric. Okay, we could really, again, always draw a curve. Okay, always draw a curve. Okay, always look eye. Okay, that's from Mr. Miyagi from Karate Kid. He's like, always look eye. Always draw a curve. Okay, yes, sensei, something like that. Okay, anyway, these are jokes, people. Okay. Okay, look up A on the standard normal table. We're not going to do that. We're not going to use a table. Okay. Okay, we're going to use StatCrunch or the calculator. Okay, or the calculator. Okay, be sure that on the calculator you never use normal PDF. It's always normal CDF. We're going to go over that in a second. Okay, so how would we do some of these on StatCrunch or the calculator? Well, I'm glad you asked. I'm glad you're here to ask. Let me tell you. Let me show you. Let me mute you. Stop video. Okay. And okay. Let's go to StatCrunch real quick. Okay. Man, I wish I could move this stupid thing. Where's my StatCrunch? There it is. Okay, can you guys see my screen? Can you see my StatCrunch?
No.
No, you can't see the StatCrunch? Okay, thank you. Okay, let me go back to the StatCrunch. Okay, so let me do a new share. Okay, oh yeah, you can't see it. Okay, here we go, screen, share. You see it now?
Yes.
Okay, thank you. Okay, so I'm gonna open the StatCrunch. Okay. Okay, I'm gonna sign in. Okay. And on StatCrunch, it's rather trivial how to do this. It's pretty easy. Easy. Okay. Because they make it basically idiot proof on StatCrunch. And we're going to go to stat, and we're going to go to calculators. Sorry, stat. Let me use my mouse. Okay, calculators. Stat. Hello, stat. Calculators, and then normal. Just go down to here to normal. Okay, get rid of this thing. Okay. And it says, oh, okay, it's a z-score. So for a z-score, the mean is 0 and the standard deviation is 1. That's what z means. Z is mean 0, standard deviation 1. That's what the z-score is. Okay, and to find a z value less than 1, you just type in 1. And it computes it, and it shows you a nice graph and everything else. Okay. And so you do z is less than 1, and that's 84%. 84.13%. Okay. From everything less than 1. Which we kind of got that before when we did 84. We kind of estimated to 84% before. This is 84%. Okay. So it's kind of good estimate. Okay. Okay, and then if you wanted to do a range of values, okay, you would hit between here. Instead of this is between, it would go between. Say we wanted to do between -1 and 1. Okay, you just hit between, okay, and that goes -1 to 1. Okay, so say that I wanted to find from -2, let's go back to some of these that we already did. We know that -1 to 1 should be 68%, right? About 68%. Okay, what about -2 to 2? We said that that was about 95%, right? -2 to 2 should be about 95%. And it is. It's about, these are, you know, rounded numbers. Okay, the StatCrunch here gives you the accurate number, most accurate that you can get. Okay, so will the calculator. I'll show you that in a second. So from 1 to 2, okay, if we do 1 to 2, it just computes 1 to 2. That's, we said it was 13.5%. Here it's 13.6%. Okay, we were pretty close with our estimate before. Okay, what about if P is greater than 2? P is greater than 2. P is greater than 2. Boom. That was, we said it was 2.5%. Here it's about 2.2, or 2.3%. Okay, Z is less than, change to a less than symbol by clicking here, less than. Z is less than 1. Compute that. Okay, oh, we already did that one. Well, Z is less than -1. Let's do a -1. Okay, and that's about 16%, which we thought. What about -1 to 3? -1 to 3. Let's do a between here for -1 to 3. -1 to 3. Compute. Boom. That's about 84%, which is what we came up with. It was 84%. Okay, and then what about -2 to 1. Negative 2 to 1. Oops, it says error. Why is it error? Oh, because I got 2 negatives. Okay, negative 2 to 1, we came up with 81.5%. This is 81.8% or 81.9%, pretty close. Okay, they would have both rounded to 82% anyway. And so we're still in the ballpark. We're still very close to home plate there. Okay. Okay. So that's StatCrunch. Okay, does that make sense with the StatCrunch? Okay. Okay, so I'm going to show you how to do this on the calculator now. Okay, let's go back to here and let me share my calculator. Okay, I'm gonna run through the new ones with the calculator. Okay, let's run through the new ones here with on the calculator. Okay, let me share my calculator real quick. Okay. Okay, so there's my calculator being shared, just my calculator. Okay, and so let's do the new ones. Let's go on to example 3 here. Okay, using the calculator. The calculator is not as simple as StatCrunch. It still is simple to me, but that's because I've been doing it a lot. Okay, but yeah, let's just go through this. So we hit second and then vars, second vars. Okay, second vars. Okay. Okay. And then we hit normal CDF. So we'll arrow down to normal CDF. Okay. So arrow down to 2, number 2, and that's normal CDF. Normal CDF. Okay. Normal CDF. I'm going to hit enter. And it tells me, okay, now if I have a newer calculator, it's going to give me this. If you have an older calculator, you just put in all these values and, okay, and with commas. You just put in 4 values with commas if you have an older calculator. Okay, so the lower is going to be, okay, -1 e to the 99, because again, I want everything below 1. And the way that I represent infinity on the calculator is this -1 e to the 99. Now, how do I put that in? I'm going to delete this. I'm going to clear it out. And I'm going to show you how to put that in. First, you want to use the negative, okay, which is below the 3. Okay, and then we don't really need the 1. We could do without that. We just need the E. And where's the E? The E is the comma key. It's second, comma. And that's the E. That means, you know, times 10 to that, and just makes a really big number. And then 99. So that's going to be from negative infinity to where? To where? Where's our lower bound? I mean, where's our upper bound? Our upper bound is 1. Okay. Our upper bound is 1. And this is a standard normal curve. So I can just hit enter, enter, 0, 1, that's correct. And then it says paste it. So this is negative e to the 99, comma 1, comma 0, comma 1. And that's the normal CDF. And this says, oh, if you want to go less than 1, then it's 84.13. So I'll write that out. Okay. For z is less than 1, this is 84.13. So if I were to go to here on my notes, okay, so z is less than 1 on my calculator, it was 0.8413. Okay. Okay, and so again, this to do the calculator, it's normal CDF. Okay, and then it's your lower, your upper, okay, your mu, and your sigma. Okay, lower, upper, mu, sigma. Okay. Now again, if the lower is infinity, then we have that e, negative e to the 99 is negative infinity, right? Because again, let's look at what's happening with this z is less than 1. Z is less than 1, again, always draw a picture. Z is less than 1 means everything from negative infinity all the way up to 1. Everything from negative infinity all the way up to 1. And then the E99 is positive infinity. Okay, positive infinity. Okay, let's do the next one here. Z is less than 1.53. So how would I do Z is less than 1.53? Okay, we'll just kind of roll through these. Okay, so let's go back to maybe I'll just share my screen so I don't have to keep clicking back and forth. Okay, so you guys see everything on my screen now?
Yes.
Okay, thank you. Okay, so so now let's do our calculator again for Z is less than negative 1.53. Okay, Z is less than negative 1.53. Okay, so again, I'm gonna go back to that second vars and then arrow down to normal CDF. And I'm gonna go, again, this is gonna be, what is this gonna be? From negative infinity to negative 1.53, right? So that's the probability that x is going from negative infinity to negative 1.53. Okay, so let's just arrow down to negative 1.53, 0, 1. These are all z-scores. So I'm going to hit enter and it pastes it, and this becomes, okay, 0.06. What is this? 0.0630, right? 30. Okay. Okay, let's do the next one here. Z is less than 1.5. What's Z is less than 1.5? Okay, I'm just actually going to arrow up and I'm going to steal this. I guess it'd be good to go through it again. Okay. So again, normal distribution, second vars. Okay, normal CDF. Okay, so negative infinity to 1.5. Positive 1.5. I'm going to delete the negative here and delete the 3. Okay, so positive 1.5, we're going to hit paste. And I get enter, and that's 0.9332. Okay, see if I can move this thing around. Cannot do the normal CDF while using TI-30. I don't know. Let me pull the TI-30 or the 36. Because I have my 36 here. Okay, the 30, no, but the 36, I believe you can. No. Let me try to restore this down here. Okay, anyway.
Professor, I have a question.
Yeah, sure.
Because I have to type it in manually to my calculator.
Mhm.
I'm having a hard time remembering how you figure for the, is it sigma after the mean? Can you use the z is less than 1.5 for example?
Okay. So sigma, you're saying? Sigma
Yes.
is just the standard deviation. For a z-score, it's 0 and 1.
Okay.
So it's just lower bound, upper bound, 0, 1 for what we're doing so far.
Oh, okay. It's always 0 and 1.
Well, for if it's a z-score.
Okay.
We'll
Thank you.
move in a second to when it's not a z-score.
Okay.
Okay, so try the next one on your own here. I'll give you a couple minutes. Try z is less than negative 2.71. See what you come out with. Okay. And then you could type that number in the chat box if you want. Okay, so second vars, right? Okay, normal CDF, negative infinity to negative 2.71. 2.71. Okay, mu is 0 because it's a z-score. Sigma is 1. Okay, paste it. Okay, so what do we got there? Okay, so I'm getting 0.0034. 0.0034. Okay, so hopefully that's what you guys got as well. Okay.
Can you show the whole thing with the lower and the upper and all of that?
Oh, say that
What
again?
you typed in for that one?
Oh, what did I type in? Second vars, so normal CDF. Okay, and then the lower is negative second comma E 99 because I want negative infinity to negative 2.71 and then 0 and negative 1, or sorry, 0 and 1. And then click paste and enter.
Is it always going to be 0 and 1 for the mean and the standard?
If it says Z, yes.
Okay.
If it says X, no. If it says Z, yes. Will always be 0, 1 because the Z score is based on 0, 1. That's what a Z score is. You're standardizing your values. Okay. Okay, let's quickly run through the next ones here. Okay, I'm not going to bother writing them down. You can write them down. Let's quickly run through them. What if we want greater than 0.05? Greater than 0.05. Okay, greater than 0.05. Let me get rid of this. Here.
We can't see, only your head, Professor.
Yeah, I know. I'm doing the screen share in a second. Here. Let me get out of this. Screen share. Okay, screen, what do I want? Oh, I want this and this. Okay. Is that better? Okay. So let's clear this. So what about greater than 0.05? Okay, so how would we do that? That one, okay, again, draw your little curve, is greater than, where's 0.05? Well, that's above 0. 0 is right there, right? And then 0.5 would be above 0, and everything greater would go to the right, right? So if we're using greater thans, everything goes to the right, right? Greater than, to the right, to the right, to the right. So this is going to be from 0.5 to infinity, positive infinity. When I go to my calculator, okay, so this is 0.5, so second vars.
Professor, we can't see anything.
We can't see anything? I'm sorry. Okay, let me try this again.
It looks like we can just see the camera pointed at your ceiling.
Okay, sorry. Let me share this real quick. Okay. Yeah, I don't know why it was not sharing. Okay, I apologize. So Z of 0.5, everything is from 0.5 to positive infinity. Does that make sense? Okay, from positive infinity, 0.5 to positive infinity. Okay, and so we're going to the right this time. So if it's 0.5 to positive infinity, okay, then we go to the calculator. I now have to share that one, I guess. Okay, so hopefully you can see everything now. Okay, and so I'm going to go to normal CDF. I'm going to hit negative, well, not negative anymore. So the lower bound is 0.5. And then the upper bound is infinity. Well, how do we write infinity? Oops. Infinity is e to the 99. That's infinity. And then 0, 1. Okay, paste that, hit enter, and that's 0.3085. Okay, 0.3085. 0.3085. Okay. Okay, let me write this one in real quick. I forgot to write that in. Okay, what about Z is greater than 1.11? Z is greater than 1.1. It's the same thing that we did before, second vars. Okay, normal CDF. Okay, and Z is greater than 1.11. So it's 1.11 to positive infinity, right? Again, looks like this. Okay, 1.11 to positive infinity. And 0, 1. Click paste. And we have this one here. Okay, so that's 0.1135, or sorry, 0.1335. Okay, what about this one? Z is greater than negative 1.25, same thing. Okay, you can try these on your own. I'm gonna put in the numbers here. Okay, I'm gonna steal from the top here and just go, oh, okay. Oops. Let me do that again. Steal that one. And go negative 1.23, negative. I'm going to insert a negative, shift insert a negative 1.23. E9901, that's correct, and I get 0.8907. Okay, for that one. And the next one, Z is greater than negative 3.5. Again, I'm going to steal that from the top. Just hit cut paste. Okay, and then, okay, this is 3.1, negative 3.1. Okay, to infinity, and that's 0.9990. 0.9990. Okay, let's move on to next example. How would we do between? Okay, between, well, just the lower and the upper. The lower and the upper are just numbers now. They're not infinity. So I do, again, second vars, normal CDF, and the lower is negative 2.41, negative 2.41. The upper is 1.03, and that's it. No dealing with infinity for this one. And that's 0.8405. Okay. What about this one, 0 to 0.75? Well, same thing. Second vars. Okay, normal CDF. Okay, 0 to 0.75. Now, 0 is not infinity. Don't make that mistake. Okay, 0.75. Okay. And then 0, 1, we're still using Z's. Okay, so that's 0.2, 0.2734, 0.2734. Okay, probability of obtaining a value that is so to answer your question, Jared, so Jared asked, he can't use StatCrunch right now. And so to answer your question, because you have access to the internet, you can Google normal distribution calculator, and there are a ton of apps that do the exact same thing that I'm doing on the calculator here. Okay. Does that help? Okay, you just Google it, normal distribution calculator, and it'll give you the same thing that StatCrunch is basically offers, but just for that this one application. Okay. Okay, so hopefully that helps. I mean, I can show you real quick if you want. Can you guys still see my thing? If you go here and you just Google, you could Google normal distribution calculator. Okay, you just hit normal distribution calculator, and there should be like 17 of these that come up. Okay, so free finds cumulative normal probabilities and z-scores fast and easy. Okay, so I don't know if this is one that works, but you can research it. So yeah, it just says what's your standards, what's your z cumulative probability, your mean, and your yeah, z is less than or equal to z. So it's a cumulative one. This one only works one direction though. So So yeah. So there are others online as well. Probably better ones that you could find. Okay. Yeah, I don't know what to tell you at that point. So, yeah, I'll think about it. I'll think about if there's any other workaround. But that web-based thing should work. So yeah, I don't know. They're all applets. Okay. If you can get in your email, you should be able to get into one of these online applications. Okay, let's go back. Okay, so probability of obtaining a value that is 1.25 standard deviations away from the mean. 1.25, what does that mean? 1.25 standard deviations away from the mean. Well, that means, okay, that the probability is negative 1.25 z and 1.25. That's what that means. Okay, or the way it's written in algebraically is the absolute value of z is less than 1.25. So that's kind of a more sophisticated way of writing that. Okay, but the top one means just the same thing. So we're going to go to second distribution. Okay, normal C to it's raining again. It's awful. Okay, the rain and the virus and everything else. This is not a happy spring. Okay, normal CDF. Okay, and we're going to go negative 1.25, 1.25, negative 1.25, 1.25. Okay, 0, 1. And we're going to paste that. And that's, I'm getting point, okay. Right. Okay, I'm getting 0.7, 0.7887, 0.7887. Okay. Okay, what about this one? Probability z is less than or equal to 1.64. That's the same thing that I wrote here. It really is just the probability of negative 1.64 is less than z is less than 1.64. Okay, so again, second vars, normal CDF. Okay, negative 1.64. Okay. Oh, upper is positive. Let me delete that. Okay, 0, 1, and paste that. Okay, and it's 0.8990. Okay. Okay. What about probability that z is less than negative 0.05 or greater than 0.05? That's an interesting one. Okay, so it looks like this. Okay. This one we can do on the calculator, but it's not going to give me the whole thing, the whole answer. I'll show you why in a second. We have this normal distribution, right? So z is less than negative 0.5, or z is greater than 0.5. Okay, z is less than negative 0.5, or z is greater than 0.5. Okay, so the calculator, okay, will only calculate one of these, but because of the symmetry involved, it's going to be 2. Okay, it's going to be 2 of the same thing. These are identical twins. Right? So what can I do? I can find the probability of 1 and then just multiply by 2. And that's what I'm going to do. Okay. So let's find the probability of one of them, normal CDF. Okay, and I'll do the upper one because it's just easier because I don't have to deal with a negative sign. So I'm going to go 0.5 to positive infinity. It's just less characters. Okay, I'm going to hit enter, 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 and it gives me this number here. Okay. 0.5 to that, right? And what I want to do, I want to multiply by 2. Multiply by 2. And I get this number here. So 0.6, okay, whoops, lost my screen there. Okay, so this is 0.6. Uh, 0.6171. Sorry. Okay, cool. Awesome. Thank you. Thank you, Jared. Okay. Online stat book. Perfect. We'll keep that in mind in the future. So I knew it was on there somewhere. So there you go. Okay. Okay. What about the next one here? Same thing, right? Same thing. We've got twins going on here. Okay, so I'm going to calculate one of them and then multiply by 2. So the probability of just one of them, second bars, okay, normal CDF, okay, of 2.2. Okay, lower is now 2.2. Okay, 0, 1, paste. Okay. Okay, is 0.0139. Again, don't forget to multiply by 2. This part here is 0.0139, but you have to multiply that by 2 because of both parts. So times 2. Okay, is equal to 0.0278. 0.0278. Okay. Okay, now let's do some examples where we don't have Z's, where we don't have Z-scores, okay? Well, it's really easy with the calculator. If you don't have a Z-score, the calculator will turn it into Z-scores for you. Very nice. Okay, let me clear my calculator. Okay, so here it says the mean for men is 69.5 and the standard deviation is 2.4. The mean for women is 63.8 and the standard deviation is 2.6. Okay, find the percentage of women meeting the height requirements, okay, from 62 to 78. So we want the probability that a woman is going to be 62 inches, and we're going to use X now. Why X? Because it's not a Z-score. X tells me, hey, we need to factor in our mean and our standard deviation. And so Z is X, which is less than 62, which is between 62 and 78. Okay, so I'm going to plug that in. Okay, so I'm going to plug that in with the idea that the mean for the women is 63.8 and the standard deviation is 2.6. So we're going to go to second vars. Okay, normal CDF. The lower is 62. The upper is 78. The mean is what? The mean is 63.8 for the women. And the standard deviation is 2.6. And then hit paste. Okay, and that comes out to be okay, what? What do we got? Okay, comes out to be 0.7. Okay, 0.75, I'll say 6 on this one, which is what percentage? They're asking for a percentage. What's the percentage here? The percentage okay. Did I skip one? I skipped one. Oh, I'm sorry. I'll go back to that one in a second. Okay, the percentage is 75.6%. Okay. What about the men? Find the percentage of the men meeting the height requirement. Well, again, probability of 62 is less than X is less than 78. Okay, but in this case, we're going to use a different mean and standard deviation. Okay, different mean, different standard deviation. So I'm actually just going to go up here and I'm going to hit enter and it'll copy and paste it for me. And I'm going to use the 69.5 and the 2.4. And that gives me 99.999, which is 99.9% of men are going to meet that height requirement. Okay, let's go back to the one that I skipped. Okay, example 8. Distribution on recent math scores were normally distributed with a mean of 68 and a standard deviation of 5.5. The professor stated that a score of 60 is the minimum needed to pass. What percentage of students pass the test? So we need the probability that X is greater than 60. So that would be a passing score. The mean is 68. The standard deviation is 5.5. So let's plug that into the calculator. Second vars, okay, normal CDF, again, we want greater than 60. Greater than 60 means that it's 60 to infinity. So this is 60 to infinity, which is E 99. Mu is 68. Sigma is 5.5. Oops. 5.5. Okay, and so we get 92.7%. Okay. Okay. Let's work backwards real quick. Okay. It says, what if I gave you the percentage or the probability and I want the score that cuts it off? Okay. Basically, to find a z-score, okay, that cuts off the lower X%. Okay, look in a table for X and match it up with z-score. We're not going to do that. We're going to do it on the calculator. Okay. In StatCrunch, you would just, again, in StatCrunch, you would just type in the error you want, and it's going to tell you the boundary. Okay, so if we go to StatCrunch, okay, hopefully you can still see my screen. Okay. Yes, that's good. Okay, so okay, so if we go to StatCrunch, hope I'm still logged in. Nope. Oh, I'm already logged in on this tab. What am I doing? There we go. Okay, we go to Stat, go to Calculators, go to Normal. Okay, and it says, oh, look, what do you want? We want to compute the percentage now, the probability. The probability is going to give you. So say that I want the, 10th percent, or we'll do I don't know, we'll do 30th percentile, right? The 30th percentile. So what's the 30th percentile? You just put in 0.3 as your answer, and we want to get the cutoff. What would be my z-score for that, for 30% of the values? Okay, well, it tells me my z-score is negative 0.52. Okay, so that's if I use StatCrunch. It's very easy. You just plug in what you want, and then it'll calculate the reverse. Okay, very easy on StatCrunch. Okay. Okay, if you want between two values, I could say, well, what's the between what two values is, say, 40%, or 40th percentile. Okay, so 40%. Oops, let me get rid of this guy. I'll go 40%, not 40. 0.4. Okay, compute, and it tells me, oh, 0.4 is between negative 0.52 and positive 0.52. Those are my z-scores for that. Okay, that's how we do it on StatCrunch. Very simple. Very, very simple. Okay, let's go back to the calculator. Okay, and then this guy as well. Oops. Okay, there we go. Okay. So on the calculator, it's a little bit more challenging, okay, but it's doable. So find a z-score that cuts off the lowest 10%. Well, let's do the 40% that we did before. Okay, so here we're going to go to second distribution, and in this case, it's the one below it. If we're going backwards, it's the one below it. It's called inverse norm. Okay, inverse norm. Okay. And it says, what's the area we're looking at? Now this will only give you left-hand z-scores. Okay, this only gives left-hand. Okay, left-hand z-scores. Okay, which means it only gives from negative infinity to z. It only gives from negative infinity to z. Only gives left-hand z-scores, the calculator. Okay, so the area that I want is the lowest 10%, the lowest 10%. So I'm going to go 0.10, okay, is the area, and I'm going to hit paste, and that's inverse norm, lowest 10%, and that's negative 1.28. That's the z-score, okay? Z equals negative 1.28, okay? What we're basically asking ourselves is the probability that z is less than what is equal to 0.10. That's what we're asking. And that z that we found was negative 1.28. So everything up to negative 1.28 is in the lowest 10%. That's my cutoff. Now, what about the highest 5%? The highest 5%. Now, again, this only gives me left-hand values. This is a right-hand value. For a left-hand value, I can do it on the calculator easily, but for a right-hand value, it's just as easy. Why? Well, because the z-score of 0 is in the middle, right? And I can use symmetry here, to give me the z-score. Because if I do 5%, which is 0.05, so second vars, and I do inverse norm, of the lowest 5%, then that's negative 1.64. So this would be negative 1.64. But because of the symmetry, what would that make the cutoff up here? Wouldn't it be positive 1.64? Yeah. Yeah, so we just calculate the negative z-score and we just make it positive. Okay, so z is equal to 1.64. If we're looking for the right-hand tail, then it's 1.64, positive. If we're looking for the left-hand tail, then it's just the negative value. Okay. Find a z-score that cuts off the highest 1%. Okay, cuts off the highest 1%. Okay, so that's the same thing we did before, but now it's 0.01. And it's negative 2.32 would be the lowest 1%. So z is equal to positive 2.3, we'll say 3. Okay, it's just that simple. Okay, find the z-score that cuts off the farthest 5%. Farthest 5%. Well, what should it be? The farthest 5%, if we look at this guy, it's the normal curve, right? If I could draw a freaking normal curve, that would be great. There we go. Oh. There we go. Okay, there's my normal curve, right? And we want the furthest 5%. Well, that's 95% would be in the middle, right? And the furthest 5% would be on the edges. Well, what should this be? Shouldn't this be negative 2 and 2? Right? Find the z-scores that cut off, and that's exactly what it is. If we use the calculator, this would be 0.025, and this would be 0.025. Those would be the percentages. The percentages. So if I use inverse norm, vars, okay, inverse norm, for 0.025, I get negative 1.96, which is pretty close to negative 2. Okay, so that's the lower z-score. Okay, so z, let me write this up here. Negative 1.96 is less than z, which
Professor, your audio cut out.
oh, I'm sorry.
It's okay. It cut out, I think, right before you started to explain the answer.
Oh, okay. Yeah, I think my network is unstable.
Okay.
So, for D, when I started talking about D,
I think it was right after you had gotten the answer up on the calculator.
oh, up on the calculator. Okay, so again, we're looking for, it should be somewhere around negative 2 and positive 2. And when we do it on the calculator, we see that it is at negative 1.96 and positive 1.96. And so, so yeah, it's it does work out. Okay. I think the whole world is on the internet right now. So at least in Orange County, the whole of Orange County is on the internet trying to work from home.
I have a question right now.
Yeah.
So when I do the inverse norm, it shows the lower and the upper, like it's not the same screen that you have.
Yeah, it's probably because you have a newer calculator. So let me show you, because there's like 3 different versions of the calculator. Let me show you on my calculator real quick. How to do that. So I'll try to share my screen.
Thank you.
Yeah. So let's I want to stop screen share. Stop sharing. Okay, so let's see if you can see my calculator here. It might be hard to see. How can I do this? Okay, can you guys see my calculator? It's not working. Okay. Yeah. So when I go to second vars and inverse norm, I get this thing here. Okay, and it says left, center, or right. Okay, left, center, or right. For what I've been doing, it's the left. So I want to click on the area and then hit left for the left tail. That's what I've been, oh, so hard to see. Okay, that's what I've been doing here. Okay, is for the left. Maybe if I zoom out a little bit. Okay, the center is when you do between stuff. That's when you do the center, and the right the right will give you a positive z-score. The left will give you a negative z-score. Okay, so I just say use left, and then you can make your z-scores positive if they're above instead of below. Okay, but the newer calculators do give you that option to do left, center, or right. Okay, does that make sense?
Mine actually just has the lower, upper, the mean, and the standard deviation, just like the other one that we were doing.
Oh
It
no,
doesn't even have that.
it's inverse norm is what you're looking for.
I am under inverse norm, but it doesn't have what you're showing. It just has the lower, upper, mean, standard deviation, paste, screen. It's number 3 under inverse norm, correct?
So it's second vars. It's number
Okay.
3, yeah, inverse norm.
Right. That's what it has, though. It doesn't have any of the screens that you were showing.
Okay, so if it's just lower and upper, then do the same thing as negative infinity to wherever. But the problem is it shouldn't be like that, because you're going to have to plug in an area. I've never seen it. I've never seen one like that. You need to plug in a percentage.
Maybe she could show her video
Oh,
of the camera.
yeah. Did you show your calculator?
I can try.
Okay. I think you had it there for a second. I can. Oh, there you go. I know it's hard, right?
It is.
Okay, let me see. Okay. Oh, okay. I see. You're in the normal CDF screen trying to do inverse norm. So you got to clear out of everything. Clear out of everything. Okay. So it's here you hit one inside the other. You've nested, kind of like Inception. There are 2 levels.
How do I clear it out, all of it?
Okay, go to
How do I clear it?
second mode. And then go back into stat,
Okay.
or go back into vars, second vars, and then the inverse norm should work properly. Okay? Does that make sense?
I got it now.
Okay, perfect. Thanks. Okay, good suggestion. Thank you so much. Okay, let's finish this up real quick, and we'll get you on your way. Okay. Okay, where's the audio there? Okay. Let me share my screen again. Okay, so hopefully everybody can see my screen at this point. Again, if you can't, let me know. Consider the normal distribution with mu of 15 and sigma of 2.5. Whoops, somebody has privileges of writing on my screen for whatever reason. Okay, so consider the normal distribution with mu equal 15 and sigma equals 2.5. How do I take your privileges away? Show names of annotators. I don't know. I'll have to play around with it. Okay, find the score that cuts off the lowest 10%. So here we're just going to do the exact same thing, but we're changing what mu and sigma are. The lowest 10%. Okay, so I'm going to go to, I'm going to turn my calculator on again. Okay, go to inverse norm, second vars. Okay, inverse norm. And this time it's going to be the lowest 10%, so 0.10. But we're going to change mu and sigma. Mu is 15. Sigma is 2.5. Okay, and we get 11.80. Okay, that's the score, not the z-score, but the score. Okay, maybe I'll say that this is x equals 11.80, right? So it's saying that, look, we have this distribution and the mean is 15 and the standard deviation is 2.5. And so what's the lowest 10%? What's the lowest 10%? Well, it's 11.80. That's what that's saying. Okay. Find the score that cuts off the highest 15%, the highest 15% now. Okay, so how can we do highest 15%? Well, I'm going to do the lowest 15%, just convert it. I'm going to convert it. Okay, so I'll show you how to convert that in a second. So let's do inverse norm. Okay. Second, vars, inverse norm. Okay, and this is 15% this time. Okay. So that tells me that it's 12.41, right? 12.41. Okay, that would be if it was 3% or if it was the lowest 15%. But there's a problem. I don't want the lowest 15%. I want the highest 15%. So I have to do some calculation here. So the distance between 15 and 12.41 is 15 minus, my answer, is 2.59. And what I'm going to do is, instead of subtracting that from 15 to get my lower value, I'm going to add that to 15 to get my upper value, my upper cutoff. And so that becomes 17.59, which is my upper cutoff. My lower cutoff was 12.41. My upper cutoff is 17.59 because they have to be the same distance from the top and the bottom. Okay, last example. Okay, the Gulfstream 100 is executive jet that seats 6 and has a doorway height of 51.6 inches. Okay, find the percentage of adult men that can fit through the door without bending. Basically, what's the probability that X is less than 51.6 inches? Okay, how tall is that? 51.6 inches. That seems very short to me. Okay, 51.6. 51, let's do this. 51 minus 48 is 3. That's 4'3". 4'3" inches. Okay, so the door is 4'3" inches. I don't know a lot of men that are 4'3" inches. So this is going to be an extremely low number, hopefully. Okay, so let's go inverse norm. Second vars, we want to do inverse norm. Or no, not inverse norm, sorry. We want to do normal CDF because we want to find the percentage. Okay, this is normal CDF. Ah, did the same thing you did. Second quit. Second vars, normal CDF. Okay, of everything less than 51.6, so that's correct, -1 E99. Okay, and then 51.6, the mean is 69.5, and the standard deviation is 2.4. Okay, and it basically says it's 0. Okay, 0, like essentially 0. It would be such a small number, such a small percentage that it's essentially 0. Okay. Okay, what doorway height would allow 60% of the men to fit without bending? 60% of the men, right? What doorway height would I want if we wanted 60% to fit? So that's a Z, we're calculating the cutoff, right? We're calculating an X value. What's the X value here? Well, and we want everything 60% to the left, right? Okay, to the left. Okay, that's inverse norm. Second vars, inverse norm. They give me the percentage. If they want you to calculate the percentage, okay, what percentage, then that's normal CDF. If they give you the percentage, that's inverse norm. If they ask
Can
for
you
the
repeat that,
percentage,
please?
yeah, if they ask for the percentage, then it's normal CDF. If you're looking for the percentage, it's normal CDF. If they give you the percentage, it's inverse norm. Okay. Okay, so the area that we're looking for is 0.6. The mean is 69.5, and the standard deviation is 2.4. Okay, and so this would be 70.1 inches, which would be what? That would be 5 foot 10 inches, basically. 10.1 inches. Okay, so yeah, that would be good. Make the doors bigger. Okay, I'm going to stop there for today. Okay, that was good. Okay, if you have questions, let me know. Okay, utilize the resources that are available to you. Okay, it's now that we're all quarantined, basically. Yeah, so my prayers are all with you, and hope none of us get sick. So I will see you on Tuesday. Again, you can, if you have an urgent matter, I'm always available by email, and show up for my tutoring sessions, please, and the sessions for the math center as well. Utilize all those resources. Okay, everything should be online 100% come Monday. So yeah, okay, Godspeed to everyone. Okay, I'll stick around for some other questions. Again, the homework is in Canvas. So feel free to work on that as well. Okay, before the due dates. Okay. So updates in regards to the exams. Okay, your YouTube video will be up when? Should be, I'm gonna upload that. You know, exams, I haven't figured out exams specifically yet. I am talking to my other colleagues about how we're gonna run that. Again, it may just be a take-home exam that you then take a picture of and send to me. Or it may be something that I do through Lumen or through Canvas. We'll see. Okay. Link on Canvas for the Academic Computer Center is not available yet. Oh, okay. Really? I'll check again on Monday. The link on Canvas for the link on your Canvas is not up yet. Okay. Yes, on Canvas, I guess you came in late. On Canvas, there is a link. Okay, yeah, thank you, Jennifer. Okay, there is a link on Canvas. Let me get rid of all this other stuff here. It's crowding up my screen. Okay. You go back in here. No, just 5.1, not all of chapter 5. We are doing 5.1. When's the next online class? Well, when is the next when? What would the next class have been? It's the same time, Tuesday and Thursday. Okay. So Tuesday, Thursday, 6 o'clock. Every Tuesday, Thursday, 6 o'clock. Be there or be square. Okay. Okay. Again, let me. When is the lecture going to be available? As soon as class ends, I'm going to upload it to YouTube. However long it takes to upload a 2 hour and 45-minute session will be however long it takes. Okay, I'll upload it to YouTube as soon as I get off. Okay. Okay. So going back to the other question, if you go onto Canvas. Okay, and you look at my Canvas page, sure. Okay, there are a bunch of things that are available to you. Okay, so now it says online. So here's my YouTube channel right here, and then the Math Center. Okay, that's tutoring. Okay, and then academic tutoring academic computing center. Okay, so these are links. Okay, and then there's tutoring as well. Okay, Math 219 workshops, Monday through Thursday. Okay, these are really good because it's 5 to 8 p.m. So those are all the tutoring things. Forget what you asked. What did you ask again? See what we got here. Oh, what is my schedule for tutoring? It's on here. So it says my personal hours online are Thursdays 1 p.m. to 3 p.m. Okay. That's what it says. Okay. Oh, okay. I don't fully understand example 11 part B. Why did we subtract? Oh, to get the distance from the mean to the x value, because I wanted that same distance below as I wanted above. So instead of being 15% below, I want the top 15%, right? So my cutoff is going to be 2.49 below 15%, but I wanted 2.49 above, or not 15%. I wanted 2.49 above 15. Does that help? Oh, okay, good. Okay, any other questions? Okay, I will. I'm gonna stop sharing at this point, and then I'm gonna upload the lecture to YouTube. Okay. Okay. Yeah, sure. No, thank you. Thank you for keeping me employed. So yeah. And safe of the virus. Yeah, everybody stay well. I'll see you next week.